Hello, this is Mrs. Scarpel, and in this video I'm going to take you through the process of finding composite functions, f of g of x and g of f of x, to determine if functions are in fact inverses of one another. So let's start here with finding f of g of x. We know what rule or expression goes with g of x because it's given to us up here as 6x over negative 2 subtract 3. So what that means is I need to find f of 6x over negative 2 subtract 3. Now something that might make this a little bit easier is if we simplify the 6x over negative 2, but for now I'm going to keep it just the way it is, just in case having it written that way works just fine. So now, inside my f of x function, wherever I have x, I'm going to replace it with this expression. So that means we're going to have negative 2. I'm going to change the parentheses in my f of x expression to brackets so that I can do parentheses around what replaces the x, which is 6x over negative 2 subtract 3, and then we have a plus 3 inside those brackets. So all I've done so far is replace the x in the f of x, and this whole thing is over 6. I notice that I don't have anything inside the brackets that need to be multiplied with the 6x over negative 2 subtract 3, so I could ignore or eliminate these parentheses and go ahead and simplify what I have inside the brackets, which is that negative 3 plus 3, so now I have negative 2 times 6x over negative 2 all divided by 6. Well, what's going to happen now is the negative 2 outside is going to cancel with the negative 2 in the denominator, which is going to leave me 6x divided by 6. And when I divide 6x by 6, I have x. Now let's do the same thing for g of f of x. We know the expression for f of x, so we're going to be finding g of negative 2 times x plus 3 over 6 by replacing this expression for x in my g of x function. So that means we're going to have 6, and in parentheses, negative 2 times x plus 3 all over 6, all of that over negative 2 with a subtract 3. Looking at my numerator, I have 6 times a fraction that has a denominator of 6. So this 6 will cancel with the denominator, leaving us with negative 2 times x plus 3 divided by negative 2, subtract 3 from that fraction. We can simplify the negative 2 divided by negative 2, which is 1, leaving us x plus 3, subtract 3, which simplifies to x. Because both of these functions ended up equaling x when we did the composite functions, or the composition of functions, I can say that f of x and g of x are inverses of each other. So because f of g of x and g of f of x both equal 0, both equal x, excuse me, f of x and g of x are inverses of each other, or are just inverses, or inverse functions. So anytime you need to determine if two functions are inverses of each other and you don't necessarily have graphs or tables at your disposal, you can always do this composition of functions, and if they both equal x, then the two functions are in fact inverses.